In this video, we're going to look at how to use the law of cosines to solve oblique triangles. We did a little bit with law of sines. So we have the formulas, have a reference triangle over here. Notice the angles are labeled with capital letters, A, B, C, and the corresponding sides opposite the angles are lowercase. So side A, opposite angle A, side C, opposite angle C, and side B, opposite angle B. So the formula simply tells you that if you take any side of the triangle and square it, it's going to equal to the sum of the squares of the other two sides. So I take side A, square it, should equal to the sum of the squares of C and B, B squared plus C squared, minus twice the product of those two sides, multiplied by the cosine of the included angle. So in this case, the included angle of those two sides, B and C, would be A. The included angle for C and A would be B. The included angle for A and B would be C, and so on. Now, if you take each of these formulas and solve it for cosine of A, or cosine of B, or cosine of C, so taking that term over to the left, on each of these three formulas, and taking the term on the left, A squared, B squared, C squared, over to the right side of the equals, we get these three formulas. Now the example I'm going to do today is one where they give you all three sides of the triangle. So remember, to solve a triangle means to find the measure of all the sides that are not given and the measure of the angles that are not given. Also remember that the sum of all three angles, A, B, and C, always has to add up to 180, and the angle with the largest measure is always opposite the longest side. So here are some of the things we've talked about in other videos. Case 1. If you're given one side and two angles, that's known as ASA, angle side angle, or side angle angle. There's a case 2. If you're given two sides and the angle opposite one of the sides, that's known as side angle. And side 2 is the ambiguous case. That's the last video that we did on this topic. Now for case 3, so on case 1 and 2, you'll be using the law of sines. I did videos on that already. Case 3, if you're given two sides and the included angle. Two sides and the included angle. Case 4, you're given all three sides of the triangle. So in that case, we have to find the measure of the angles. Case 3 and 4, again, you'll be using the law of cosines. For 1 and 2, it's the law of sines. So let's look at the first triangle that I have here. Say solve the triangle with given information. So we're given side A equal to 4, B equal to 3, and C equal to 6. I've partially done this just to make the video a little bit shorter. And what I'm going to do in this one, we're given all three sides, so we need to find the measure of angles A, B, and C. Now I'm going to choose to find the angle with the largest measure, which is going to be the angle opposite sides C equal to 6. 6 is the angle, the side with the longest measure, so the largest angle will be angle C. That's opposite side C. So if I use the formula for cosine of C, this is simply saying cosine of C will equal to, and in the numerator, I'll have the sum of the squares of the included sides. If you note over here, A and B, the included angle is C. And then you have the side opposite that, which is side C. The formula then says cosine of C will equal to sum of the squares of the other two sides. So that'll be 4 squared, 3 squared, minus the square of the opposite side of this angle. That would be side C, which is 36, divided by twice the product of, again, the sides of the angle, A and B. So that's 2 times 4 times 3. So if I do these calculations, 4 squared is 16, 3 squared is 9, 6 squared is 36. So I have 16 plus 9 minus 36, I get negative 9. And then the denominator, I have 2 times 4 times 3, that's 24. So I get minus 11 over 24. Now, one thing I want to point out to you here, when you have the cosine of, in this case, angle C equal to a negative number, you know right away that the angle has to be obtuse, larger than 90. Okay, because the cosine of any angle with terminal side in the second or third quadrant is negative. And remember, we're only interested in angles from 0 to 180. We don't want angles larger than 180. So in this case, I know for sure that angle C is obtuse, greater than 90. There's only one possibility. Now with sine, remember, the sine of an angle is always positive in quadrant 1 and quadrant 3. So if you compute the sine of 30, that's going to be the same as the sine of 150 using reference angle. Okay, when you're solving trig equations, you use the reference angle. So that's why in using the law of sines, we had the ambiguous case. Because when you have the sine of a coming out positive, you could have a angle in first quadrant, which would be acute, a supplementary angle, which in the case of 30 degrees, the supplement of that is 150. So those would be two possibilities. And you have to test those out. That's why, as we saw in the ambiguous case in the law of sines, you could have one triangle possible, two triangles, or in some cases, no triangle. So in this case, I have cosine of C equal to negative 11 over 24. So if I take the cosine inverse of both sides, I get C then should equal cosine inverse of negative 11 over 24. Let's use the calculator. And again, make sure that your calculator is in degree mode. Use my cosine inverse of negative 11 divided by 24. Hit enter. And that gives me 117.3. 100, run that out to one place. 170 degrees, 0.3. Put it here. Angle C then is equal to 117.3 degrees. And so we need two more angles. Now I have C as an obtuse angle. Now I know for sure that the other two angles have to be acute. They have to be less than 90 degrees, both of them. Otherwise, I can't form a triangle. So let's suppose I wanted to find cosine of A. Cosine of A then should equal to the sum of the squares of the other two sides. So that should be B squared. That's it. That's 9. I'm sorry, C squared. C squared is 36. And then minus, okay, the side opposite this angle, which is 4 squared. So this is 4 squared is 16. And in the bottom, I might have 2 times the product of the other sides. Again, the same ones that I had here squared. 3 times 2 times 3 times 6. This is equal to, so we have 36 minus 16 here is 20, and then add 9, that gives us 29. And in the bottom we have 2 times 3, 6, and then times 6 again, that's 36. So then, in the same way, A should equal to, taking the cosine inverse of both sides here, this should be cosine inverse of 29 over 36. Let's take the calculator over here then. And we're going to take second, again, cosine 29 divided by 36. Hit enter. And we get that A is equal to 36. Round up to one place here, 36.3 degrees. Now we need angle B. I could do it the same way using the formula for cosine of b, but since I already know two of the angles, I simply add these up and subtract from 180. Let's just say (180) minus 36.3 minus 117.3. Hit enter, and we get angle B is equal to 26.4 degrees. And this is actually the solution. We were given all three sides, and we found the angles. Now, one of the reasons that I found the largest angle is because sometimes it's a little bit less tedious to use the law of sines. And once you know that the remaining angles are acute, you won't have the issue with the supplementary angle. Are there two solutions? You won't have that issue if you know that the angle you're finding is acute. So you don't have to test the supplement to see if that's going to work, because you already have an angle that's obtuse, so you know you can't have more than one. You can't have a triangle then. But just to show you here, those are the angles. Angle A, 36.3. Angle B, 26.4. And angle C, of course, is 117.3 degrees. So let's suppose I went ahead and found angle C. So we said this was 117.3 degrees. So let's suppose I wanted to find angle A using the law of sines. Okay, I could find all three using the same formula here, the corresponding formula for a particular angle. But if I go this one and say, well, let's use the law of sines, you can say sine of, let's suppose we'd only done this one, and we wanted to find angle A. So you could just say sine of A. Remember, it's over the opposite side. So opposite side is 4 units. And then you have to set this equal to the sine of a known angle. Okay? We weren't given any angles, but we found one here. So I could just say this is the sine at 117.3 degrees. And the opposite side is 6 units. So then sine of A multiplying both sides by 4 here. Let's cancel this 4 here, and then the other side multiplies it by 4 here. So I got 4. Sine of 117.3 degrees divided by 6. So then, take sine inverse of both sides. So then I would just say then that A is equal to the sine inverse of this quantity. So this quantity would go right there. So let's do it in the calculator over here then. So second, I want sine inverse now. Sine inverse of 4, and that's going to be the sine 117.3, close parentheses, divide by 6, and then close parentheses, and then hit enter. And we get A is equal to 36.3 to one decimal point. And I don't have to do a confirmation to make sure that this is a solution because of the fact that we found the largest angle and we know the other ones have to be acute. So I don't have to test out the supplement angle to see if it works. It's not going to work in this particular case. So we found all three angles. Angle A again was 36.3 degrees. Angle B was 26.4 degrees. And angle C, of course, is 117.3. Thanks for watching, and we'll see you next time.